Hey everybody. So just wanted to make a video kind of talking about LabVIEW and security, right? So this is all leaning into the OWASP top 10 for desktop, right? So OWASP is an organization that's just looking at security of software, right? So what are the most common things, occurrences security-wise, and what can you do to try to prevent that? So they've got kind of the OWASP top 25, but they also have specific to desktop applications. What are the things you need to be careful of from a security standpoint? Just because, right, a lot of different organizations, right, your large-scale software companies are typically doing more web-based cloud-type applications, not so much desktop applications, and there just are a lot of security differences between the two. Wanted to walk through this in LabVIEW. This is actually a document NI has put together. I just wanted to kind of walk through it and also add some kind of dialogue and discussion to each topic. So the first thing is injections. So just looking into this, right, reading the description, issues such as SQL, LDAP, XML, and OS command injection, etc. occur when untrusted input is passed to the interpreter as part of a query command. An attacker can trick interpreters to execute arbitrary commands to perform unwanted operations or gather unauthorized data. So basically the idea is, right, if you have maybe some sort of field that pops up that allows a user to enter some information, and that is being built into like a query to like a SQL database, or could be running some command on the command line. If someone is aware, right, they can format the input data in such a way that it would execute either a secondary query or could do something else malicious, right? So, or just, there's times, right, where you can pass in a condition that would force a true, right? Where, you could then retrieve data that's beyond what you were trying to receive that could contain, information about other people or other proprietary information. So the idea is, right, we just need to be preventing that from happening. So LabVIEW specifically checks the data. Let me just read this. Data entered into a front panel control is checked by LabVIEW. Incorrect data types are rejected by the control element. So, for example, if you have a numeric on your front panel or on like a dialogue or something, it's actually going to prevent you from entering text into it. So you can't go enter, alphabetic characters. Most of your special characters aren't allowed either, right? It's going to allow like a decimal point, for example, but you're not going to be able to do other things. So there's automatic protection there, right? When you're using a string, right, anything can go into a string, right? It could be numbers, could be letters, could be special characters. So when you're using a string, you need to be especially careful. But if you're asking a user to enter some number or something, there's already automatically some checking there, right? That's going to prevent against SQL injections, OS injections, etc. Also going on, numeric data is limited to plus or minus infinity by default. Using control properties, the range can be limited. So there still is some risk, though, with the number, depending on, what number the user enters, right? Because by default, it's going to allow any number at all. So you don't want someone to enter a number that would force some sort of injection type scenario, right? So for example, you can bound that control to only accept certain ranges. For example, if we're letting a user type in some sort of test result, right? And the test result is always expected to be within 0, it has to be greater than 0, and it never should be more than, let's say, 7, just some random number. Depending on what the test is, may or may not make sense, right? You can actually limit the range of values that the user can input such that they can never go 0 or less, and they never can input more than that. And that way, right, they never could put in like a -1, and maybe the way your code's set up, it doesn't know how to handle a -1, and that could open up the window to some sort of injection. So that would be something to look out for. So in terms of static analysis, right, LabVIEW directly doesn't have a way to check for this. I have a few VI analyzer tests that I built, kind of custom tests that detect like OS injections and stuff. And I'll actually make a separate video on those, here in a little bit. But yeah, basically the idea is, right, you need to consider when you're working with any of these things, SQL injection, LDAP, XML, or if you're using system exec, right, just looking at if there's any possibility for an injection. So if you're using the database connectivity toolkit, the best things you can do is always use parameterized queries. If you're using a query that never accepts user input, you don't necessarily have to worry about injection so much, right? If it's just, reading data off of a sensor and then writing that to a database, right? There's no user interaction. There's no way someone could actually force an injection. Same thing with OS command injection, right? If every command you're sending to the system exec is a string constant, well, there's no way there could ever be injection, right? Or if maybe you're formatting a string, but what you're formatting never uses user input, right? Like maybe you're passing in a file path, but that file path is basically generated automatically from LabVIEW, and you have control over that, right? You can prevent injection that way. So there's a lot of different things you can do. You just need to make sure that you are protecting effectively against injection. LabVIEW natively does help with this by not allowing you to input, data in different fields that's not supported by those fields, right? So, for example, you can't put, alphabetical characters or special characters into a numeric. Next thing I want to talk about was broken authentication and session management. So reading the description, it includes issues such as insecure authentication implementation, authentication bypass, improper session, etc. An attacker can exploit insecure implementation in order to compromise user sessions, passwords, and keys, or to assume the identity of the user of the application. So just going into the LabVIEW section, LabVIEW does not manage users. This must be managed by the OS on the system running the LabVIEW application. Using drivers, LabVIEW may access hardware devices connected to the system. Depending on the interface type, the device may have more or less authentication as it connects to the system. For example, a GPIB device responds by GPIB address, and no further verification of the device is managed by the driver. If the threat of a counterfeit device exists, the developer needs to implement additional checks that vary by device, for example, by checking the serial number of the intended device. So, as this mentions, right, LabVIEW is not managing users. So in terms of user permissions and whatnot, that's really handled on an IT level, not necessarily LabVIEW. Now, if you need to allocate certain permissions to certain users, there's different ways that you can do that. You can create your own user management system. You could set up like a database with user accounts. User can create a new account and store their username and like maybe a hashed password in the database or something. Ideally, though, the best way to manage that is using Active Directory. So your IT team is already managing user accounts and permissions. If you can just use LDAP to query Active Directory and set up custom user groups in there to validate permissions, that's really the best way you can do that. And again, LabVIEW natively isn't managing your user accounts for you. But if you need user accounts, I highly recommend that's the route that you go down. It makes it so you don't have to worry about securing your own user management system. You already have like an enterprise level system that is actively being managed by your IT team, so might as well leverage it. In terms of devices, right, depending on what the devices are and what the implications could be of connecting different things, you may or may not need to check that the device you're connecting to actually is the device you're connecting to. Serial, I think, is a lot lower risk. And a common practice, right, is just to use an IDN query when a device supports that, where you say, hey, what are you? And it will return typically like the make and model of the device. And you can validate that the device you connected to is the device you're expecting. Now, if someone was really malicious and they created a counterfeit device that responds the same way, that can still fool you. So you may need to implement additional checks. But at the same time, right, it's all case by case, right? Sometimes, right, you may be talking to like a power supply. And if someone were able to create a counterfeit power supply that responded to the same commands, there may not even be huge security implications, right? They may not be able to access anything proprietary. Maybe they cause some disruption in your testing or whatever. But yeah, so it is a case-by-case basis. But in most cases, right, just issuing like an IDN query, just having some sort of way to say, are you what I think you are, is pretty good. And if you need additional checks beyond that, then it's up to you to kind of figure out what those checks are. If you have some sort of unique kind of identifier, like it could be a serial number, could be some sort of fingerprint of some sort, some sort of key of some sort, just to validate that the thing you're connecting to is the thing you're expecting. Sensitive data exposure. So unintentional exposure of sensitive information such as PII, financial information, healthcare information, or application keys and secrets. This may include data in a memory post-app logout, logs with sensitive info, hard-coded secrets in files, etc. An attacker can use this information to carry out identity frauds. So directly, LabVIEW does not categorize data types as sensitive. Programmer must identify when data is being collected, stored, or transmitted, and check that this data does not include sensitive data. So out of the box, right? LabVIEW is not checking what's sensitive and what's not. It's up to you to define that. And it's also you to define how you're storing this information that is sensitive and needs to be protected. So general guidelines, right? When you're transmitting data, you need to be using secure protocols for this data. So if you're using TCP, use the TLS function so that you can transmit that data securely and encrypted. No one can capture that data during transmit and be able to basically steal the data. So if you're using HTTP, make sure you're using HTTPS. Set up your web server such that it's using the appropriate certificates and keys so you have secure communication. If you're using TCP, use TLS. If you're using WebSockets, make sure that you're using encrypted versions of those WebSockets, right? So if you're using the Media Mongrels WebSockets library, there is a secure WebSockets add-on that allows you to basically use encrypted WebSockets. So depending on the protocols you're using for transmitting this data, just make sure that you're using methods that can be securely encrypted and decrypted. And as a last result as well, there's always VPNs. You can use VPNs as well. So if I create like a VPN tunnel, I can transmit plain text data. It could be like UDP, right? And it's encrypted as it goes through that VPN and it's decrypted on the other side of the VPN. So that's another option, is leveraging a VPN as well. So that would be data during transmit. We also need to be protecting logs with sensitive info. So if we're logging test data, we need to be making sure that those logs aren't easily viewable from anyone. So, just logging to data files. So it could be, any type, right? It could be a CSV file, a TDMS file, just about, any type of file. We want to make sure that those logs are protected. So we can do that a lot of different ways. We can encrypt the files themselves, which is one thing you can do. Especially if you're using files like SQLite, right? If you're using SQLite, you can actually use SQL Cipher to encrypt the entire SQLite database file, and that requires basically a password to decrypt that file so that people can interact with it. So that's one thing you can do if you're working with local files, is encrypt them. Another thing you can do is control, and this will involve your IT team, is control where those log files are going. So you can have those log files go to certain maybe network file share locations, or even local on disk locations, where maybe only certain individuals have access to them, or maybe even only one individual has access to them. So where you log the data makes a difference, right? You don't want this data being logged somewhere where anyone can publicly go access it and either copy, take it out of the facility, share it, or modify it in some way or anything like that. So kind of two options, right? Control where those log files are going, or encrypt the log files. Lastly, just want to talk about hard-coded secrets. So, the worst thing you can do is have secrets hard-coded into your code. So if you have a VI that's maybe connecting to a database, you should not have a string constant in your VI that is the username and the password and all of that information, right? Ideally, you want to separate the lock and the key. So the first thing you usually look to is just, create a file, some sort of config file that will have that those credentials stored in it. And then the application will just read that file, and then it has the credentials. So that is better than having the credentials hard-coded. But still, if those secrets are stored in plain text in that file, it's still relatively easy for someone to steal those credentials. So they can just, if they find the file, they now have access to those credentials. And they can even see, what things your software is accessing to be able to see, oh yeah, I read this file over here, and now I know where the secrets are. So now you need to look at a way to secure those secrets better. So files can be fine, right? And you can even encrypt your config files as well. So you can have some sort of way to encrypt those files. There also are secret stores available. So there's lots of different secret stores you can use for storing secrets specifically. I've got an API that works with the Microsoft Secret Store tools for Windows, if you're interested in that. I've also worked with Keeper, and there are different other cloud web service or cloud secret store tools out there, as well as different enterprise tools you can install in your facility. So there's lots of different ways you can manage this. You just want to make sure that those secrets are not something easily accessible. So for sure, make sure they're not in your code. And so at a bare minimum, just have a config file that stores those. But ideally also you want to be protecting that config file so that it is either encrypted or you're pulling those secrets in from a secure location. And that would be how you're going to prevent sensitive data exposure. Next one is improper cryptography usage. So issues such as usage of weak cryptographic algorithms, weak keys or secrets, custom cryptographic functions, and insecure key management. An attacker can exploit these flaws to retrieve the sensitive information or to attack the users of the different instances of the same application. So NI says LabVIEW does not include encryption that meets FIPS 140-2 requirements. This may be done with a third-party toolkit or through user-built VIs. So there are some cryptographic functions that ship with LabVIEW, mostly just for kind of hashing. So you've got kind of some SHA functions, some MD5, etc. And these actually aren't FIPS 140-2. So you want to make sure that you're using good cryptographic functions. So regardless of whether you're doing, AES encryption, RSA, doing different signing and verification algorithms, hashing, etc. There are different levels of these algorithms, and we want to make sure that we're using good cryptographic functions. So for example, I've seen a VI that someone generated that used FFTs to essentially encrypt numeric data. So they would take a whole bunch of numeric data, run it through an FFT algorithm, and then to basically decrypt that information, they were using an inverse FFT to get that back. So they're basically taking their data, storing it in the frequency domain, and then when they wanted to view it again, taking it back into the time domain. So realistically, not cryptographically secure. And really, it's what I would call security by obscurity, right? Someone who looks at the data might be like, I don't know what this means, and walk away. But anyone who's really serious about attacking your information can find a way to basically reverse engineer that. So, not a cryptographically secure method. So if you're looking at good ways to do this in LabVIEW, I have two recommendations. The first one is going to be using the Microsoft cryptography function. So if you're on Windows, and this only works on Windows, installed with your system is a .NET library for cryptography. And in here are functions for signing, verifying, generating keys, encryption, decryption of different, algorithms, hashing, all sorts of stuff. So that's a really good place to start if you're looking for secure cryptographic functions. My second recommendation is Bouncy Castle. So Bouncy Castle is FIPS certified, and it's basically just a open source community cryptography library that incorporates a whole bunch of different algorithms. If you go to my GitLab I've started mapping the functions in Bouncy Castle into LabVIEW. So it's basically just a .NET DLL. So I've started mapping different functions there. I haven't finished yet. The goal is to map the entire library, but I'm not done yet. So if you want to work with it right now, feel free to pull what's in my GitLab right now. And more features will populate as time goes on, as I have more and more time. And feel free to also, contribute as well if you're interested in this, helping develop this. It also has one cool thing about Bouncy Castle is it also has some post-quantum cryptography functions available. So kind of the next generation of preventing against basically attackers leveraging quantum computing to break cryptographic algorithms. So the way that we're deriving keys right now, we may have like a public key and a private key, right? And attackers right now, if they have that public key and are trying to derive the private key from the public key, can take, hundreds of years, right? It could be this massive effort with current computing technologies. But with quantum computing technologies, they may be able to break that extremely quickly. So there's a whole bunch of what they call post-quantum cryptographic functions in there, which are specifically targeted such that even with quantum computing, it would still take a significant amount of time to be able to break that encryption. So that would be my second recommendation is Bouncy Castle. If you're interested, go look at my GitLab. I have a library in there with some functions mapped. I really want to finish it out. I just keep having stuff pop up, so I haven't really had the time to finish working on that library, and there are a ton of things in there. So it's a pretty decent sized project, but as well, if anyone wants to contribute, feel free to issue a pull request. Next is going to be improper authorization. So authorization flaws include weak file and folder permission per user role, missing principle of least privilege approach, improper user roles, unauthorized access to registry or environment variables. An attacker can gain elevated privilege of the application or of the target system. So again, LabVIEW does not manage users. This must be managed by the OS on the system running the LabVIEW application. So really kind of the same stuff we were talking about on DA2 here, right? A lot of this access to these file shares and whatnot, different folders, etc. Your IT team is managing that. That's typically something that's outside of your control. Really on your IT team to manage that. When it comes to kind of external devices, though, right, you want to make sure that if there's a risk of connecting to a counterfeit device, that you've incorporated, additional checks to make sure that that's not an issue. Next, we've got security misconfiguration. So flaws include misconfigured group policies, registry, firewall rules, etc., missing file content type check for file processing apps, misconfigured name pipes, misconfigured supporting services used by the application, misconfigured third-party services. An attacker can gain system access by exploiting these flaws. So LabVIEW does not manage network domains, firewalls, etc. This must be considered at the system level. At the LabVIEW level, this may need to be measured and tracked on the deployed system for file changes. So again, this is largely an IT issue, right? Your IT team needs to be setting up group policies such that firewalls are consistent throughout your organization, that network domains, everything is kind of set up such that it is secure and consistent throughout the organization. The only place where I think this kind of bleeds over into a LabVIEW developer's responsibility is when we start getting into like embedded, kind of the RT target type systems like Compact Rio, right? Your IT team usually doesn't know how to administer these devices. So it's often up to you. For example, Compact Rio, right? When we're talking firewalls, there is actually a firewall on your Compact Rio. By default, it does nothing at all, though. It just allows all data in and out from anywhere, anyone, etc. So you can go configure that firewall to block, ports, to block different, protocols, etc. You can even use it to rate limit things. So I think that's when you start bleeding it over into the LabVIEW realm, is you want to make sure that you are protecting your system. You want to be making sure that things are configured properly. And if you're using compact RIO, right, you want to make sure that your different compact RIOs are also consistent, right? The security configuration you've applied to one, you should have applied to another, and you should have a baseline configuration, typically, right, maybe an image of a certain target that you can deploy to all of your targets. You can maybe apply different software, but having like a base image you can apply to all of them that is secure is important. One thing it does mention is you may need to track file changes, right? So just be aware of if certain files on the system have changed, right? Typically, right, maybe this file should never change, but someone's gone in, they've linked it to try to make it connect to something else that's not the intended target in some sort of config file. So tracking file changes is a good way to do that. If you go, I have a separate video I made a few weeks back on a LabVIEW file integrity monitor. This is meant to be deployed on your system as a service, and it basically just logs changes to files, so when they're created, renamed, edited, etc., and logs all of that information to a SQLite database that you can then view. So that's a way that you can check if files have changed, and there are also other ways that you can do that as well. Reading the file properties is not a great way to do that, though, because I can write to those properties as well. So if I update a file, I can also tell it, hey, change your last updated time back to the time before I actually updated you. So if you're just reading the file properties to see when it was last changed, to see if it has changed, that's not a very good way to do that. I can fool that pretty easily. So using my file integrity monitor, they're not actually able to trick that, as it's using the file watcher built into Windows to actually monitor what files have changed. So next one, insecure communication. So insecure communication issues include usage of weak TLS or DTLS cipher suites, protocols, plaintext database connections, usage of plaintext communication protocols such as HTTP, COAP, MQTT, etc. These flaws allow an attacker to perform man-in-the-middle attacks in order to sniff and manipulate the data of an active connection. LabVIEW developers may create routines to transmit data using a variety of technologies. Developers must implement encryption or other security around the communication. So I already kind of talked about this, right? But there are insecure communication methods and secure communication methods. So we want to be sure that for anything that it could have sensitive data or could have important information that an attacker could use to harm a system, we want to be sure we're using secure methods. So if we're using TCP, make sure that we're using TLS. If we're using HTTP, make sure that we're using HTTPS. And other protocols, right? We can use non-encrypted protocols if the data doesn't matter. But if we really have to use those non-encrypted protocols with sensitive data, we need to be incorporating additional safeguards. So ideally like a VPN, right? Somewhere where we can transmit the data securely and it's encrypted as it goes through the VPN. So a couple different options, but you need to make sure that we use secure communication. Next is poor code quality. So issues related to absence of secure coding practices, such as missing code signing and verification of file integrity, missing code obfuscation, lack of binary protection, memory leaks, buffer overflows, etc. An attacker can reverse engineer the application in order to obtain information about the application logic, business-specific proprietary logic, or can exploit application processing using binary attacks like DLL preloading or injections, overflow, underflows, and memory corruption. So the note here for LabVIEW developers may create good or poor code. NI publishes code standards for LabVIEW, and you can use VI Analyzer to check for those standards. So there's a lot of different standards that are kind of just universal, right? So checking for memory leaks, right? Making sure that you're closing all .NET references. There's some stuff that's just, you should be checking for these things. And there's some stuff that's just style related, right? And a lot of that needs to be defined by your organization. So VI Analyzer has a preset, basically set of tests that it can run on your code, and you can basically check to make sure you're meeting those standards. If you just go run VI Analyzer though, and especially if you've never done this before, if you go open VI Analyzer and tell it to scan your project, and it asks what tests you want to run, and you may just go check all of them. The results are just a giant mess that's really hard to really dive into, right? You see, especially if you're scanning a big project and you see, it ran 80,000 tests and I passed, maybe 60,000 of those and I failed 20,000 of those. What do I do, right? Which test do I actually care about? So I highly recommend, if you're planning on using VI Analyzer, that you create a custom configuration. And I think your organization should figure out what your code standards should be. And that way you can make sure that you're meeting those code standards defined by your organization. I think that's the best way to do it. If you just run VI Analyzer, you can get some good information, but gleaming through the whole sea of test results, and a lot of it might be stuff you don't even really care about, right? It's a mess, right? I remember my first time running VI Analyzer. I just selected every test because I wanted to run everything, and I saw the results and said, I don't even know what to do with that. So, you really do want to figure out a good configuration of tests that your organization cares about and run those specifically so that your tests are specific to the requirements your organization has set out. So you make sure you have good code quality per your organization standards. Next, we have using components with known vulnerabilities. So it includes usage of outdated softwares, obsolete components, services of OS or third-party vendors. An attacker can exploit the vulnerable components and services to retrieve information or to compromise the target system either locally or remotely, depending on the exploit. So LabVIEW uses third-party and open-source components. The system must check that none of these components have vulnerabilities. So you can get software bill of materials on LabVIEW, on the LabVIEW runtime engine, etc., and different NI software. If you reach out to NI, I believe it's just security@ni.com, you can get these SBOMs and you can check them for the components and all of these things for vulnerabilities, but also your own applications that you're building. You'll want to make sure that you're not using components that have vulnerabilities. So those components, beyond just LabVIEW, right, could be .NET or C DLLs that you're calling in your code. It could be Python code that you're calling through Python nodes. It could, different things that you could be using. You want to make sure that those components don't have vulnerabilities. So the best way to do that is to create software bill of materials of your own and upload those to an enterprise level tool that will scan all of the components for known vulnerabilities. And they also have the ability to notify you of vulnerabilities as well when new vulnerabilities are discovered. So if you're interested in creating your own LabVIEW software bill of materials or SBOMs, there is a open source toolkit available through Media Mongrels, if you're interested in that. I've also kind of taken that open source toolkit and built a GUI interface for it. So you can basically, from a file control, select your project, it will scan it, you can generate your SBOM, and you can go save it as a file. So if you're interested in doing stuff like that, that is a way you can do that. It generates a Cyclone DX software bill of materials. Last thing is insufficient logging and monitoring. So this includes missing or insecure implementation of logs, improper parameters within audit logs, missing regular monitoring to detect abuse, etc. Centralized logging and monitoring are used to detect, analyze an incident, and detect an active attack, respectively. Sometimes attackers try to manipulate this data to prevent alarms with many techniques like time stomping and many others. Such issues also have to be focused. So directly, LabVIEW is not logging user activity or data actions. So this may be done with third-party tools or at the system level, or may be hard-coded by the developer. So there are enterprise level tools out there that will log what your software is doing, that will say, oh, this software just touched this file, the software just did this, etc. It doesn't track everything that's going on in your code necessarily, though. So I think it's helpful to create your own system logs, and the format in which you do that is kind of up to you, right? There's not a, this is how you have to do it, but you should be logging information, in your code to say, hey, this user just, opened this up. this program up. Hey, this user just did this, started this test. This user just did this. So you want to have some sort of traceability on what is happening in your code. And there's a lot of different ways you can do that. Right? You can do to local files. You just need to make sure that you're controlling those files so that no one can go in and manipulate them or delete them. There's syslog is a great way to do that, where you can send basically that information over the network and have it logged over the network, which I have a library available on my GitLab if you're interested in that supports UDP and TLS for syslog. So you can send that information to a collector, and it has a device and collector implementation for both protocols. So that way you can transmit that data across the network and have it logged in a secure location. That way, if you ever need to go look at what was happening, you can. So you just need to be tracking how things are happening in your code. One last option I just wanted to highlight, if you're on Windows, is the Windows event logs, which I also have an API available on my GitLab if you're interested, which allows you to log data to those Windows event logs, but also read that data back out of the event logs and apply filtering and whatnot. So that's another great way to just say, hey, this is what's happening. You can log errors there. You can log just informational stuff like, hey, the program started up. Hey, this sequence finished successfully. Hey, this test results for this, job were just saved, et cetera, et cetera. So all sorts of different things. So those are kind of the top 10 things you need to be aware of when developing desktop applications. These are the top 10 biggest issues security-wise with desktop applications. So when you are looking at how to develop secure LabVIEW desktop applications, these are the 10 things you should be focused on the most. You should be looking at making sure that you have created sufficient protections against these 10 issues. And if you do, not to say that your code is guaranteed secure, nothing bad could ever happen, but you are going to be far better off because these are the most common issues out there. And as I mentioned, right, the kind of explanations I've been giving and solutions I've been giving are not exhaustive, right? There's other solutions out there for all of the things that I've mentioned. I just wanted to highlight some of the different ways that you can do these things so that you can make sure that you're developing secure LabVIEW code. So hopefully that was helpful, and thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.